Yeah, yeah. Hi all. Hi, David. Welcome to the presentation. So this is artificial advanced artificial intelligence project 2 presentation. So we are me and Sai Kumar Javaji uh, going to present this presentation about this and along with the working demo about the project. So if we go into the slide, so like the task for the project is like to detect the facial recognition of this 46 presidents of USA. So using the artificial intelligence, so like how the model will be working and how the data format and how the design diagram, like we are going to discuss on this contents in the on the coming slides. Yeah, we go on to the next slide. Like the introduction, like the purpose of the project is to like there are a lot of images of the US presidents like that is need to be detected using the machine learning algorithms. So how it will be going to detect it, like so is a technique, the technique behind to detect the um, detect US presidencies, like how will be the how it will be detecting, like is machine learning or AI involves. So where the technology that has been involved here is like detecting involves the detecting when the one existing with pre-organized, like it need machine need to be learn machine need to be learn about, like whenever the image or any has been seen, that need to be pre or pre-recorded in itself. So how it will can be happen, like our, like we're going to do having the first of all, initially we are having the our data set is having the all the 46 US presidents, and becomes a multi-class classification problem. So like there are data set has been divided into the training data set and a testing data set, with the different with or without having the overlapping images. Like we will going to train the machine to detect the presidents. Yeah, if you go on to the next slide, so how AI involves here. So AI is like a branch of so object recognition is the branch of AI. So where it will deals with the robots and the devices. So like the implement AI implementation having the like ability to recognize or diverse objects and other entities, like and also to say object recognition or image recognition, I can say it. So how it will be helping the robots and artificial intelligence algorithms like to work on this identify special person or special thing or special object, to say. So like using the video and camera images. So and object location is also more refined in the sort of image classification, where AI based model predicts on features, things that like it will be utilizing the picture or image recognition techniques in the AI, and to say the discovery and restriction of these things in the picture, that adjust the present preset arrangement of the classes that has been and frequently been bounding on the box location, like to say like YOLO approach, the CNN technique that have been like it will be using like the machine will be to say to simply to say like a machine need to detect a image. So to in order to detect the image, so how machine will be known like this is a perfect image that has been matching image that it has been recognized. So machine need to learn for initially, it need to learn from itself, or else it need to be trained by the external entity. So this machine can detect it, so machine can detect it as quick as possible, and it will be like easier to do as work as possible. So like this is why machines like getting the, to say machines are getting the brains. That's it. Yeah, if you go on to the next slide, a simple neural network like will be like predicting the bound of box a class and probabilities directly by the full images, like to simply to say if we can use a matrix, I can say. So a matrix having the 1 0 or like number series, like if the certain image has like one facial recognition, let's say look at the eyes, it will be having the zeros, the dark colors will be seeing as zeros, like the higher intensity will be white color will be seeing as one to the 9. So like to that extent level, whenever the one face has the matrix type, we can detect to compress it as like this. So how like each certain part, like is eyes, eyebrows, and nose and mouth, like it will be like merging in a certain pattern. Like whenever that pattern is being repeated in the next or images, or else next if we got in the video recognition, it will check that compares with the same kind of matrix comparison. Like it will detect, okay, like this is the person which matches the matrix with this is a person. So this says, AI says, okay, this both persons are same. So this is how it will be detected. So like how the whole detection pipeline, like in a single network, optimized and end-to-end directly detection performance. Okay, and then if you go on to the next slide, yeah. So YOLO, like what this model, like what this model like will do is like YOLO will be the is initially introduced for as a first object detection model. So there are certain models are there. So like to say this YOLO is one of the best one. This combined bounding box prediction and object classification in a single end on the differentiable networks. So it trains model with the YOLO data format and image data sets. This is how like it will be working on this. Um, if you can go on to the next slide, like how the model will be going to work, I will going to say is, so how the data format need to be, like the data format need to be in like the name of the marks record must be the name of the picture is had to be .txt rather than a jpg. So I said it like jumping to the box is how it will be recorded as a bouncing box in each line with one that line. So the class number of article is bouncing in the box. So like normalize focus on pixel and the jumping into the enclosed terms of width, and it would say and then normalized focus pixels, that is like bouncing box with regards to that certain level, and then the normalized width to the width of the jumping box. So and like it will be level of the bouncing box also, I can say it. So this is how the data format need to be, like where the it can machines can able to learn is easily as they can be trained. Okay, so like that is been very easier format to do detect and all. Okay, if you go on to the next slide, so how the process to say yeah, so how the process that has been working, as I said it, uh, the input frames, like it will be the image data set in the sense like whole data set of having the 46 US president, we will segregate into the setting the names, like 46 names. So each name will be the each person who is having the same kind of pattern matching in the matrices. So the process here works over here, like the image data set we are just using for object detection, how it will be detecting the certain type of pattern matching, the classification of this detection using the method of object proposed and object detection technique. This technique will be like how the output will be like they are getting the we are getting the how the output like is each image will be the set in the processed into the frames. So those frames will be checking this the matched data, or else set into the one kind of set of pattern, all the normalized image data set having the detected pattern. So it will store that kind of pattern, and then confidence of like it will get the confidence of the recognition to say, like when you give the out certain output of the one picture, like it will be having the one president. So it will detect that pattern, like how confident the machine will how much percentage and how much accuracy to say it the ground truth of the object. Let's say if you go on to this I can say it like detecting this pictures is especially like that accuracy, like that matrix percentages will be like how that model will be merging with the percentage of the values that has been matching that image detected values. So that is how it decides the confidence. And then if you go on to the next slide, here the process I have explained, right? So this is the design diagram, how like we do use the data set and a tested data set and a training data set. Like the model will be taking the considering this all this data set as a one of the learning experience, like to design this model. Like this model will detect the into the like detect the precedence and output stored into the folder. Okay, like it will be getting stored into the one of the folder. It will be storing as a tf-lite files, I can say, like that. The model will be saving that kind of output into the some certain folder. Okay, so the next coming to the slides, my coming slides and the working demo will be going to explain with my friend Sai Kumar. Okay.
Yeah, thank you, KK. When we got the project, like we both have downloaded the images from the internet. For 46 different types of presidents were downloaded for each president, more than 20 images, and we have collected nearly more than 1K images. And while dividing, we divided the 800 samples as the training set and 200 samples as the testing data set. So this is the training data, which we fed to the model, that consists of 800 images. In the next slide, like you can see, this is the testing data set. Wherein the testing data set consists of the 200 images, which this will be input to the model, and from these, for these images, model will be detecting the who the president is, and will be giving the output like president with the confidence value and the name. Yeah, process, how the process, what the process we have followed here. Yeah, the object detection repurposes the classifiers to perform the detection. So the major concept of YOLO, we have used YOLO CNNs to do the object image classification. Image classification is used in the most of the applications. So here, like the major concept is to build a CNN network to predict 7-730 tensor. It uses a CNN network to reduce the spatial dimensions to 7 to 7 with 1024 output channels to each locations. That means we are modifying the image, the original image. So here the object, we frame object detection as a regression problem to spatially separate the bounding boxes associated with the class probabilities. So with probability and with the classic regressions, we have modified the image and we have gathered some data to the model. So YOLO performs a linear regression using two fully connected layers. For example, to make a 7 to 2 boundary box predictions. To make a final prediction, we keep those with high box confidence scores. We keep only the confidence greater than 0.25 as our final predictions. But what we do the modifications on the image, but after modifications is done, we discard the modifications and we keep the image as it is. This is the process we followed to train the model. So with this process, we gave the 800 image to the model, and we made it. We learned it. We built the model and downloaded the model. Next, this one, yeah. Now prediction. Now for prediction, we need what we need to do is load the Keras model. First step is like in the step in the before, we have prepared a model. Now here the step is to load that model. Next, load our take photographs of the take the testing data set of the 200 new presidents and input these 200 images to our model. The model expects input to be color images with a square shape of 416 pixels. That is how, even though the images are not in the coding, we will modify them and we will input them to the model. We will want to show the original photo again later, which means we will need to scale the bounding boxes of all detected objects from the square shape back to the original shape. As such, we can load the image and retrieve the original image. This is what we are going to do. See, this is the results. This is how the results look like. Here you can see different presidents.
Yeah, like this results looks good as someone like it will be
Yes.
detecting.
Yes, it is like rotating the face and telling the name William J. Clinton 0.89. That is
Yeah.
89% confidence. Robert C. Hoover 83%. This
Yes,
Thomas
yes.
Jefferson 87%. I think
Yeah,
Jefferson is like Jefferson City. Ronald Reagan 84%. This is
yeah,
the output we are getting. Like we are we are rounding the face and displaying the name and confidence value. This is our result. Now we'll go to the demo part. Yeah. So this is the project structure. Here, this is the image data set. We have two folders. One is Kiki, you can screen my screen, right?
No, I'm just able to see you the presentation only. Like the screen sharing has been happening only the presentation.
Okay.
Yeah,
Okay.
right now it's been merged. You need to reshare it again once again.
Yeah, I'm sharing it back. You now you are able to see my full screen.
Yeah. Yes.
Yeah.
Yes. Yeah.
So
I'm able to.
this is our project, and here we have an image data set. In this we have two folders. One is testing images. In this we have 200 images only, like which we need to text. And the training images, these are the images we fed to the model to train it. In this we have like 800 images, more than 800 images of the 46 US presidents. So these both are the training and testing image data sets. And coming to our project, this is the project code. This is the project code. Like we have different this we have written the code using the JetBrains IDE PyCharm. Here we have the models. We have created some models in that, and the main thing here is like main.py. If you run this file, it will load the model, and it will take the images, and it will take the images and it will do the predictions. Now I will show it in PyCharm. So this is the PyCharm. Now here you can see testing image folder. I am taking the folder of testing images. You can see Sai image dataset testing images. So here you can see like Sai image dataset testing images. So I am taking all these images and feeding this to the algorithm, and this is the main.py. So now I am running the file like py main.py, enter. So it is predicting the US presidents, like it will be doing the process. It takes some time. Let's wait for the response.
Reading the image and prototyping and just processing of the images along with comparison of the models that has been happening. Yeah.
Now, yeah, it's done. Check response in the runs folder. Now I'm going back, and yeah. So here is the runs folder. Go here, detected results. This is the results detected. Now, if you open any image, so it is telling he is Abraham Lincoln with the confidence of 73%.
Yeah.
Like this one, see, we can see he is Barack Obama with 81, the confidence of 81%.
Yeah. Looks
this
good.
Is also Obama with 76%. This is also Obama with 91%.
Yeah, that's nice.
So he is like Franklin D. Roosevelt.
Yeah.
This guy is like Franklin D. Roosevelt only. Like only for he old one, his images are not clear. Only for this guy, the confidence is low. For others, the confidence is low. He is very high. The algorithm is working with more than 95% of the confidence. For example, he is like George Bush with 53%. So it is detecting the presidents correctly, but the confidence levels are also good. See James K. Polk with 78%. So this is how the project is working. This is the detect result set after the algorithm is run. So before we have the image data set, testing images. See here, this is the image we have taken and applied the algorithm, and that is we identified, and with the accuracy we got the result in the. We got the result. Yeah, this is the one. Yeah, that is how that is the output of the project. It is running quite well. And now coming to the conclusion, we have used YOLO and designed with the help of CNN neural networks. We have used the image detection techniques, and we are able to predict we're able to predict who is the president. We were able to predict the president name with some accuracy. See, for this process, like we have divided into training and testing data set. 80% of the data is used for training and 20% for testing. And this model worked with 92% accuracy using YOLO CNN networks. We have achieved this. Yeah. These differences.
Yeah. Yeah, like I would like to thank you, the professor, and like we got the opportunity to work on this as well before like working on the gun detection. So like this is the another experience that we got. I would like to thank a professor and Sai. Like we have a great chance to work on these things. Yeah, yeah. Thank you all.
Professor David Dye. He helped us a lot. Because of him, like we got good knowledge on the such algorithms. Also, that is very important uh, for the job, and also projects. The gunshot detection, we got good name because of the project, and this is also we are happy. We are happy that to work with you. Thank you for giving us this opportunity.
Yeah, yeah. Thank you, thank you, thank you, professor.